Hi, I'm Chandler Bentley. I'll be talking about redox reactions and half reactions.
I'm Mimi. I'm going to be talking about the final project.
Hi,
and
I'm
half
Maddie. I'm
reactions.
going to be talking about pre-design process and scientific principle.
Redox reactions. First, what are redox reactions? Redox reactions are chemical reactions that involve the transfer of electrons. So, two types of transfers are when oxidation, when a substance loses the electrons, but is also referred as the reducing agent, and you can use the acronym OIL for this. Oxidation is loss. Reduction is when the substance is reduced and it gains electrons, but is referred as the oxidizing agent. And you can use the acronym RIG, reduction is gain. So an example of this in a chemical equation, CO has a charge of 3 plus, but down here has a charge of 2 plus, and that's reduction because it gains electrons. And oxidation, here you can see as Br has a charge of negative, but then -1, and then on the other side of the equation, it is neutral. This may be a little bit confusing because electrons are negatively charged, so even though it looks like this is like losing things, it's actually gaining electrons because electrons are negatively charged. So when it's more negative, that means it's reduction, but when it's more positive, it's oxidation.
This was our first design. In our first design, we used a grapefruit as a source of energy. We used galvanized iron for an anode and copper for a cathode. Next, we attached the anode and cathode to the voltage meter. This combination of fruit and metals wasn't ideal and only produced 2.4 volts of electricity.
We started off with 1 lemon and added magnesium anode, and then added a copper cathode, and later on we added alligator strips to both. We then did the same thing with another lemon. We used alligator clips to connect one cathode from one lemon to one anode from the other lemon. Then we used alligator clips to connect one cathode and one anode to the voltage reader. Our final voltage with this one design was 3.33.
This was our third design. We realized through our experiments that more fruit you have, the higher voltage you will get when you plug it into the voltmeter. Therefore, we wanted to use more fruit in our design, but there weren't enough alligator clips. We ended up coming up with a design that incorporated putting the anode and cathode in the back of the lemon and attaching each lemon to the back of the other lemons. Next, we attached the voltmeter to the anode and cathode at the end of this circuit. The voltmeter read 3.12 volts.
This is our final design. Once we got the alligator clips, we squished the lemons and limes to make the electrolytes flow. We connected the alligator clips to the opposite anodes and cathodes and plugged it into the voltage meter. After doing this, the voltage meter read 9.5.
Someone take a picture.
Take your time.
Take a video.
So I've been doing
It's the moment. You guys. I am impressed. 9.0.
What are half reactions? Half reactions show the transfer of electrons from what is being gained or what is being lost. Since our anode happens to be magnesium, it is being oxidized. As seen in this half reaction, it has a neutral charge because it's not transferring any electrons at the moment. But when it transfers electrons to copper, as seen in the equation, it has a +2 charge because it's it's losing electrons, and it can be seen by the +2e, which stands for electrons in the equation. Now, as for copper, it is being reduced because it's the cathode. The cathode on the reactant side is where you would show the +2 electrons. Since it is losing electrons, it starts with the +2 charge, and then the +2 electrons, and then as it goes to the other side of the reaction, it's being reduced, so it is gaining electrons, so now the charge is neutral.
So an element's electronegativity is based on its location on the periodic table. So the farther to the right it is, the higher it is, and the farther down it is, the lower it is, which is why fluorine has the highest electronegativity out of all the elements. So then above here you can see magnesium has a +2 charge, and then a negative 2.37 reaction potential, and then copper has a +2 charge as well, but a positive 0.34 reaction potential, and that determines which one is the anode and the cathode. So the anode is the one with the lower reaction potential, and the cathode is the one with the higher reaction potential. So the reason why we chose magnesium as our anode is because it had a rather low reaction potential, but then the reason why we chose copper as our cathode is because it had a rather high reaction potential, which means that magnesium having such a low reaction potential will transfer a lot of electrons to the cathode, which is copper.